NASA's plan is to build a base on the Moon before sending humans to Mars so that the process of reaching Mars becomes shorter. SpaceX founder Elon Musk wants to win the race to go to Mars. Apart from this, European and Russian space agencies are also talking about sending humans to Mars. But after landing in Mars's harsh atmosphere, how will humans survive there? Because unlike Earth, the biggest necessity for life, oxygen, is not present on Mars. What method has NASA found to produce oxygen on Mars? And why won't the method by which the International Space Station produces oxygen work on Mars? Welcome back, viewers, to another episode of Computer Technology Support. There are many reasons behind humans' desire to live on Mars, including scientific exploration and the factor of space curiosity. However, amidst these desires, there's also a compulsion or fear that due to some disaster on Earth, the human race might become extinct. 76 million years ago, dinosaurs were wiped out from our planet, and climate change, which we are seeing on Earth, is a possible threat. This is perhaps the biggest reason why someone will become the Neil Armstrong of Mars in the coming times. On one hand, Elon Musk had initially intended to colonize Mars by 2026, but now his prediction has been pushed back to 2029. You've slightly put back. The expected date to put the first human on Mars till 2029, I want to say. 148. Yeah, so let's see. We have built a production system for Starship, so we're making a lot of ships and boosters, but the question is not who will go to Mars first. The question is how will humans survive after going to Mars? Indeed, many properties of Mars are similar to Earth's. For example, a day on Mars, also called a Martian day or Sol, is only 39 minutes longer than a day on Earth. It also has different seasons, just like Earth. Besides this, Earth has ice caps at its poles, and so does Mars. Earth has an atmosphere, while Mars also has an atmosphere, albeit a thin one. But one thing that is completely insufficient for humans to live on Mars is oxygen. So how will this oxygen gas be produced on Mars, not just for 1 or 2 people, but to sustain an entire colony? When talking about keeping humans alive in extreme situations, the first thing that comes to mind is the ISS, the International Space Station. It has spent 25 years in the harsh conditions of space, and even now, it continuously produces oxygen and fresh water for humans. There are always 4 to 5 astronauts present on the International Space Station, whose daily water requirement is at least 45 liters, which translates to 1,350 liters per month and 16,200 liters per year. Besides this, 1,000 kilograms of oxygen gas is used annually on the ISS. How is so much water and oxygen produced 400 kilometers away from Earth in space? For this work, 2 systems are installed on the ISS. One is the Water Reclamation System, WRS, and the other is the Oxygen Generation System, OGS. Why can't we install these 2 systems on Mars? To understand this, we first need to know how these systems work. The Water Reclamation System collects water from human waste, urine, sweat, and humidity, and then purifies it to make it drinkable again. Astronaut Douglas H. Wheelock once said, "Our coffee from yesterday is the coffee for tomorrow." The WRS system purifies the water already present in the ISS and makes it reusable, thus saving 98% of the water from being wasted. 436. Next to it is the Oxygen Generation System. This system takes a little water from the WRS and then passes it through a special process to produce breathable oxygen. We studied this simple process in 5th grade called electrolysis. Electrical current is passed through water, which causes the water to break down into oxygen gas and hydrogen gas. Oxygen gas is used for breathing, but hydrogen is a very dangerous and flammable gas that could burn the entire ISS into a fireball in seconds. This hydrogen gas is not wasted. Instead, it is put into another system called the Sabatier system. This system combines the waste carbon dioxide from the astronauts present in the ISS with hydrogen gas to produce water, methane gas, and a little heat. The water is reused, and the heat is sent to the heat management system. However, methane gas, which is very important on Earth, is released from the ISS into space. Methane gas, which is also a type of fuel, can be used to generate energy and heat, but it is wasted because it requires oxygen to burn, and oxygen is very precious on the ISS. If we consider the entire oxygen and water process of the ISS, it depends on refueling missions. Although it is 98% efficient, there are still losses and leakages in every system. This is why water and oxygen are sent from Earth to the ISS every 6 months or a year. These refueling missions are very costly, with the cost of transporting just 1 liter of water 400 kilometers above to the ISS being more than $25,000. Therefore, producing oxygen in the same way on Mars, which is 22.5 crore kilometers away, is by no means cost-effective. For this, a system will have to be developed that uses the resources present on Mars itself to produce oxygen from them. In 2021, NASA's Perseverance rover was sent to Mars. It had a device installed for this experiment, named MOXIE, which stands for Mars Oxygen In Situ Experiment, because the water source on the ISS is refueling. But to carry water to Mars, one would have to go to its polar caps or drill several feet below to extract ice. For this reason, MOXIE uses carbon dioxide from the Martian atmosphere to produce oxygen from it. To explain it in simple words, the Martian atmosphere is 95% carbon dioxide. MOXIE pumps carbon dioxide from the outside atmosphere, pressurizes it, and then passes it through an electrolyzer, where it is heated to a temperature of 800 degrees Celsius. This separates the oxygen gas from the carbon dioxide. This electrolyzer is made of gold because gold is an excellent heat conductor, which protects the other parts of Perseverance from the heat. In this process, along with oxygen gas, carbon monoxide is also produced from carbon dioxide. The disadvantage of this is that if the carbon separates completely in this process, it can form a layer of carbon, just like what is seen at the bottom of a cooking pan. And this layer will not take long to damage Perseverance. For this reason, this process is performed with great caution. But how much oxygen does MOXIE produce at one time on Mars? MOXIE requires a lot of energy for this process, which is why NASA only runs it occasionally when energy is saved from the solar panels. So far, it has produced only 122 grams of oxygen, which can keep one person alive for only 7 to 3 hours. If more oxygen needs to be produced on Mars through this system, a larger version of MOXIE will be needed, along with a large power plant to run it, and this is the biggest challenge so far. Now, the point to understand here is that MOXIE first compresses carbon dioxide with the help of a compressor and then heats it to 800 degrees Celsius. Both of these processes require a lot of energy. To solve this problem, scientists are working on a future technology in which the carbon dioxide molecule can be broken down at a lower temperature. In this, instead of heating carbon dioxide, oxygen molecules will be separated from it by creating vibrations within it. Currently, this technology has been tested in the lab, but due to Earth's high atmospheric pressure and temperature, it is not possible to conduct this experiment on Earth. However, the atmosphere of Mars is perfect for this work. Whatever the technology, our target is to produce oxygen on Mars using things that are present there, and the devices that produce this oxygen should not be dependent on Earth, because the ISS is only 400 kilometers away from Earth. If its oxygen generation system breaks down, sending astronauts back to Earth is not that big of a problem. They can put on their emergency suits and wait for refueling for a few hours, or they can also go back to Earth. But if, after colonization on Mars, there is a problem with the oxygen generation machine, there will be no option for refueling, and returning to Earth will not be so easy. Hopefully, you will like and share this video from Computer